Hey everyone, it's Mr. Carr again, and today we're going to be looking at what's called the slope-intercept form of a line. So to help us with this, we are going to do these two examples pretty much at the same time. I'm going to start with filling out this table using all of my x's and plugging them in there. So if I have 1/2 times a negative 2, that's a negative 1, plus 2 is 1. 1/2 times a negative 1 is a negative 1/2, and then plus 2 is 1.5. Plug in 0. 0 times 1/2 is 0, plus 2 is 2. 1 times 1/2 is 1/2, plus 2 is 2.5. And then 2 times 1/2 is 1, plus 2 is 3. Over here, plug in negative 2. That's negative 2 times negative 2 is a positive 4, minus 3 is 1. Negative 2 times negative 1 is a positive 2, minus 3 is a negative 1. Plug in 0, I get negative 3. Plug in 1, I'm going to get negative 5, and then I plug in 2, and I get a negative 7. Okay, so let's go ahead and plot these on the graph. So I got negative 2, 1, negative 1, 1.5, 0, 2, 1, 2.5, and then 2, 3. Over here, I've got negative 2, 1. Whoops, negative 2, 1 is over here. Okay, then negative 1, negative 1, 0, negative 3, 1, negative 5, and 2, negative 7. So a little bit extra space, but not a whole lot. All right, we're going to find the slope of each of these. And for our purposes, slope is going to be labeled with the letter M. So we can do which any way you want that you've done in the past. I'm just going to do it as counting them out when I look at the graph. So I'm going to do like the rise over run. So for example here, I'll pick this point and this point. Goes up 1, to the right 2. So the slope of line A is 1 over 2. If I do it here, I'm going down 2, and then to the right 1. So that's a negative 2 over 1. So when you look at these two slopes, here's where I'm going to play the pause the play posit. Do these two values look familiar? Okay, now that we're back, hopefully you answered where they appeared then. They're right here. Here's my slope there and my slope there, right? Feel like a coincidence? I don't think so. That's supposed to happen. So that's what that's what happened there in this case. So what happens is slope is in the equation attached to x. All right, now let's do the same thing. We're going to try the y-intercept. Remember, the y-intercept is the point where the line crosses the y-axis. So if I look at that here, I've got the point 0, 2, and 0, negative 3. I could also identify them from my table right there. It's whenever my x is 0 that I get my y-intercept. So it's 0, 2, and 0, negative 3. Well, let's answer this question. Do the y-intercepts that we just found, do they appear in the functions from problem 1? If so, where do they appear? Okay, now that you're back, hopefully you said this. 0, 2, there's 2. 0, negative 3, there's negative 3. So you may have done some slope-intercept form before, but we just want to make sure we're clarifying how these all connect. How does the equation connect to the table, connecting to the graph? So we have it, it crosses, let's see here. It's at the last number in the equation is the y-intercept. So using what we just did, we should be able to find an easier way to graph the lines from problem 1 without making an XY table. And that's the goal here. Let's make it a little bit more shorthand for our graphing purposes. So I want you to go ahead and explain that. How, knowing that I have two key information here. I have my y-intercept and I have my slope. How would you go about trying to graph this? Okay, now that you're back, so here's how I do. We start with the y-intercept. Okay, I would start my graph at 0, 2. Then apply the rise over run. Okay, and that should be rise over run, not rise over none. There we go. All right, so we're going to practice that now. So in slope-intercept form, it's in this form, y equals mx plus b. The m in the front of the x, that's my what's called coefficient of x, is the slope. Okay, that is helping us with our change. Every time we move over in the x direction, we are moving a certain amount in the y direction. Okay, the constant term, the b value at the end, that's my y-intercept. So in this form, this y equals mx plus b, x and y are the variables. So x and y can vary. We use variables as placeholders. They are representing unknown numbers for now. Okay, m and b, though, those are called parameters. And we did this in our last activity. We're kind of looked at, well, what happens? What happens when I change these parameters of m and b? But now you got to make sure you understand they are very specific to for each linear function. So these are going to be fixed values. They, like, once you have a special function, whatever it is, m and b are going to just kind of be frozen. That's going to stay that way. So this is how we can use this now. Now that we have this information, we don't have to make an XY chart. All I need to do is I need to identify my slope. So here's -2/7, and then b is 4. So what this means is I'm crossing at 0, 4. So 1, 2, 3, 4 right there. With a -2/7, I can actually do one of two things. I can treat it like it's a -2 over a +7. So that's a rise over run of -2. So that'll be 1, 2 down, and then +7. So 1, 2, 3, 4, 5, 6, 7. Okay. The other thing I can do, because this is true, but this is also true if I did this. If I did a +2 for my rise and I did a -7 for my run, well, then I can go 1, 2 up for my positive, and then 1, 2, 3, 4, 5, 6, 7 to the left. It doesn't matter as long as I'm still applying that overall negative slope there. So -2 over a +7 is the same thing as a +2 over a -7. All right, so let me do this one for you. The slope is 5/3. The b value is a -7. So I'm going to start with the fact that this is crossing at 0, -7. So I got 1, 2, 3, 4, 5, 6, 7 down here. My rise and my run is 5 and 3. So I'm going to go 5 up, 1, 2, 3, 4, 5, and then 1, 2, 3 to the right. Now, all I need are these 2 points. I know you might have heard from teachers in the past that you should do 3 points. Nothing wrong with that, but the bare minimum is 2. I can only make one line here. I could have gone -5, -5, or -3. This is the same thing to get an overall positive slope. The problem with that for me is I would have gone off the graph. I would be down here. I don't feel like dealing with that, so that's why I chose up 5 to the right 3. All right. I'm going to have you answer a couple follow-up questions for these 2 problems here. Okay, now that we're back, let's look at one more style with this problem here. Now that we practice graphing it, we should be able to write our slope, y-intercept, and our equation of the line. Let me just make sure. Based on the graph. I'm going to do the first one with you, and then you're going to finish up with the second one for number 8 here. So we need 2 pieces of information. We need the slope, we need the y-intercept. Personally, I like to start at the y-intercept. In this case, it's -4. That's where I'm crossing the y-axis at. So after that, I just need to find any point that it definitely crosses. I feel pretty good about this point. That one's pretty easy. So that means my slope is going to go up 1 to the right 2. So my equation should be y equals 1/2 x minus 4. Okay, and I'm going to go ahead and let you try the second one. I want you to identify the slope, the y-intercept, and then write into an equation. All right, now that you're back, again, start with the y-intercept. So I'm crossing at the point 0, 1. Okay, so that should be y-intercept is b is a 1. Then I pick at any other point, so I'll pick like this one looks good. So I'll go 1, 2, 3 down, and 1 to the right. So that's 3 down, 1 to the right. So my equation is y equals negative 3x plus 1. All right, and that concludes our work on our slope-intercept form. And this is one of our last videos this is the last video that we'll be covering for this unit. We'll do a couple other things. We'll have a quick practice, do some algebra practice, do a quick quiz on this, and then we'll finish with some fun things for you to do during the last part of this class. So I will talk to you later. Make sure if you have some trouble with this, please reach out. Talk to you later.